Thank you. Marvelous. So this is quite interesting because if you were listening to the chap who was just talking, he literally just took a massive dump on TEEs. So I'm going to argue a slightly different case for TEEs. And just a quick intro about myself. So I'm Gavin. I've been embedded in Web3 since about 2015. I had the pleasure of building an enterprise-grade blockchain in that time, and I co-founded a startup, and I inaugurated a DAO. So I've done a few things. And you might notice I'm English. And in England, tea is quite a big deal in England. In actual fact, there was a, come on in, take a seat, don't be shy. And there was actually a survey done in England a number of years ago, and the English population were asked to pick one thing that represented England. And the one thing they chose was a cup of tea. A cup of tea represents an entire country. However, I'm not going to talk to you about tea. I'm going to talk to you about TEEs today. Slightly different kind of tea. Before we do that, I'm going to suggest there's a problem with Ethereum right now. And that problem is that all data on Ethereum, by design, is completely transparent. All data is visible. So things like MEV. MEV's a thing because data's transparent. And now there's some regulators around the world that want to put a stop to MEV. They might even start calling MEV illegal, for example. So that's a problem. You can find out sensitive information about people if it ever ended up on the blockchain. And essentially that transparency is really limiting what we can be doing on Ethereum. A quick primer on TEEs then. It's hardware based. If you imagine the CPU and the memory on a server, there's a ring-fenced part of that CPU and memory, and that ring-fenced area is entirely encrypted. So any computations that you run within that ring-fenced area, nobody can access. The operating system can't access it. A compromised operating system cannot access it. Even the human being operating that server cannot access the computation happening within that TEE, which is pretty cool, because immediately, if you want to run software and within that software you want to have some confidentiality, you want to have some secrets, then you can run that within a TEE and nobody else can see it. They can only see the output from that computation. They're pretty common. So TEEs probably been around a bit longer than you might realize. They're all every phone in your pocket has a TEE. All laptops have a TEE. A couple of years ago, there was a bit of news about Intel deprecating their TEE, Intel SGX being deprecated on laptops. The reason they did that is because they were using TEEs for digital rights management. And everybody stopped watching Blu-rays on their laptops, so they decided to deprecate that. However, Intel are still doubling down on TEEs for their server class Xeon processors. So they're pretty common. They are literally everywhere. They might even be in your fridge. And there's a really neat feature with TEEs. If you think back to what I was saying about you're running this software in a confidential encrypted space, then you might think, well, hang on, how do I know that that software that's in that encrypted space, if I can't see into it, how do I know it's running the thing that I want it to run? How do I know it's not adding a zero onto the loan that I owe to Bob over there? And so there's this concept called attestation. And attestation is the feature of TEEs that lets you validate that the software you think is running inside the TEE is in fact running inside the TEE. And you can go through a measurement process to prove that. So you gain confidence that it's doing what it should do. So before I get on to Web3, let's think about, we've got these TEEs, we've got encrypted spaces within these TEEs. We've got these TEEs within servers. We've got a whole ton of servers living in the cloud. Take your pick. Azure, IBM, Alibaba, they're all running VMs that are capable of running a TEE. So if you start connecting these together and you run the software within these enclaves, then you get an encrypted network out of the box. I mean, that's great, isn't it? You suddenly encrypted your entire network. You're not just relying on TLS for your inputs and outputs. You've even got all the stuff that's happening on that server, on that entire network, is entirely encrypted. And even more than that, because TEEs are capable of running a more complex software environment, you could run an entire Ethereum virtual machine within a TEE. So you're running the entire EVM within an encrypted space. And so you think, well, if I can run an EVM, I can run a smart contract. So you suddenly have what we call programmable privacy. So the developer building the smart contract can decide what data they want to be private and what data they want to be public. And that's quite unique, and I'll come back to that in a minute. But there are myths around TEEs. You've probably heard about TEEs already. You know, you've got to be a rocket scientist to use them. They're really difficult to get hold of. They slow everything down. They get hacked all the time. And anyway, we've got ZKP and FHE coming along. Why do we have to care about TEEs anymore? Well, as a supporter of TEEs, I'm going to try and argue against some of those. So in terms of developer expertise, if you deploy a VM into Azure properly today, that VM, a VM with TEEs, that VM will behave just like a non-TEE server. Nothing new, it's straightforward. In terms of performance, we've run performance tests, and we think there's about an 8% decrease in performance for computation. 8%, not much. When you're talking about microseconds, really isn't much. In terms of hacks, okay, so there have been hacks, but all the hacks I'm aware of have been very much in lab conditions. And when I say lab conditions, that's somebody with physical access to the chip. They're doing some microscopic analysis on that chip, and they're able to infer some information. And if there's other hacks that are more deep than that, like there was one recently that I think the previous panel were referring to, they're on deprecated hardware or they're unpatched hardware. So TEEs are more secure than you might be led to believe. And ZKP, yeah. So ZKP is going to save everything, right? Because ZKP is awesome, and it is awesome to a point. However, I mentioned programmable privacy earlier, the ability to have a mix of private data and public data, all in the same smart contract. As far as I know, you can't do that with ZKP right now. In addition, because TEEs have been around for such a long time, they are battle hardened. You know, they've been tested. Banks have been using them to move their data around for a long, long time. And ZKPs, they will get there. FHE will get there. But I think they've got to go through a process of battle hardening, really. They need to become more commonplace. All the bugs need to be flushed out. So that technology will get there, but not just yet. I think TEEs is the solution for now. So when you're using trusted execution environments, the reality is you can actually achieve something very much akin to access control for your data on a blockchain. So let's forget about the privacy labels for now. Let's just consider you've got a ton of data on the blockchain and you want Alice to see it, but you don't want Bob to see it. And that right now is impossible on Ethereum. But if you're running an EVM within a trusted execution environment, then actually you can start having that distinction. You are providing access control to that data on the blockchain. Your computations that are happening within that trusted environment are trusted. And that's important because when you consider, you want to be moving money around, you want to be doing significant transactions, you need to be able to trust, not just you, but even the regulators want to be able to trust that what's happening within that encryption environment is what you say is happening. So if you run it in this ring-fenced enclave, we know that nobody can access it. We know the server operator can't access it. We know there's no human beings that can access it. Therefore, you've got trusted computation. Again, you're running software in a trustworthy way. Scalable and efficient, I think we can argue that TEEs are they're going to help with a sensible cloud deployment of TEEs. They're going to be able to run far more complex software than other encryption alternatives. And when you look at who's using trusted execution environments, it is the banks, it's the global institutions, and they've ticked off on using Intel SGX in their environment. So there's already an element of approval achieved for this kind of technology. So let's get back round to why we started this whole conversation. TEEs and Web3, do we think there's something there? Well, I think it's a perfect match. I think it's a match made in heaven. You're providing Web3 developers with the power that Web2 developers take for granted right now. So let's think about why TEEs and Web3 make sense. Let's consider AI agents. I imagine a world where we live in, where we all have personal AI agents. So I've uploaded a whole ton of data to an AI agent, and it's making decisions on my behalf. You know, I want to go and buy a new pair of trainers, don't know what to buy, AI agent will help me make a decision. It's only going to know those kind of things, or if I've got health issues, it's only going to know those things if I've provided a lot of sensitive information to that AI agent. And so if you're now running AI agents and you're keeping the data private on the blockchain, then on Ethereum, then you'll be able to keep that data just to yourself and to your AI agent. Similarly with oracles, so you can have a data oracle, but you're only providing that data to people that pay for it. So take Netflix, for example. Netflix wouldn't be making billions of dollars of revenue every year if we could all see the data that they're streaming. You know, if you're watching Netflix and you want to watch it too, you don't want him paying to watch what you've paid for. So there has to be a degree of confidentiality or a degree of encryption or a degree of access control to be able to achieve that. And we can do that with TEEs. Innovative DeFi, so I talked about MEV protection, but things like dark pool trading, things like private trading strategies, identity management, so being able to keep your identity in a safe environment so you're not having to repeatedly provide the same identity information, but you're keeping it private. And then on-chain games. And on-chain games is quite interesting because when you think about most games, there's a degree of incomplete information games. There might be a map that you have to reveal, or there might be some cards that your player has that you don't have. So it's incomplete information. Not every game is a game of chess. So you need to have, if you're ever going to get to the point where you've got fully on-chain games, there does have to be an element of hidden information. For example, some of you might be familiar with Battleships. So Battleships is a game from the 1980s. 2 players, 1 player would hide some ships on their board and you'd have to try and hit their ships. And the hidden data element there is quite obvious. It's the ships. What isn't quite so obvious is the public information. So the public information is, we both need to know where those hits are going. I need to know so I can say whether it's blown up my ship, and you need to know where my ship is or is not in the game. And you could achieve that with a smart contract running within a trusted execution environment that's running the entire EVM, because your smart contract can provide both public and private information. And then, well, this is Web3, right? Why don't we scale it up to a few thousand people, and those few thousand people are trying to hit the ships that are hidden within the smart contract. And suddenly you have quite an interesting game that's not been seen before on Ethereum. So at 10, we think that TEEs are the means to unlock the true potential of Ethereum, the means to unlock Web3, definitely in the near term. We'll see what happens in the next 3, 4, 5 years, but for now, it's time for T in Web3. Thanks.
Wow, what a session. And we have time. We actually have a couple of minutes for questions, guys. So any questions from the audience? I'm sure someone has a question. I've got a question. Are you going to be around this, when are you leaving Napoli, first of all?
Fairly shortly.
Oh, you're not flying this evening, are you? Oh, you're going straight to Token. A few of us in the team are also heading off to Token, but I think what's really interesting, I think, for the project is, I'm sure you guys have heard about teas, but to see it in the capacity that you've just explained to us today. So I suppose what I would love to ask is maybe something, you know, that you can tell us about TEN, something that maybe is launching this year for you guys, something behind the curtain that we, you know, maybe a little bit of mic drop maybe before we finish today.
Well, I guess thanks, James. Good question. I think I guess the timings is relevant. So TEN's been in testnet for about a year. We're getting over 8 million daily interactions on there, so we're definitely kicking the tires. We should be launching their main product, code freeze in early November. You know, hopefully 6 weeks after that we'll go live. But I guess some of the launch stats are interesting. So we're talking to a launch pad who would be able to have, you can actually have a degree of privacy about your involvement within that launch. We've got a couple of DEXs on there as well, so they'll be launching with us, and DEXs that are bringing new innovative ways to make use of DeFi. So yeah, it's going to be a busy couple of months for us. Yeah.
Sounds like it, and it's always busy when you're attending events, isn't it? I mean, it's full on. Also, is there a screen there where people can connect with you, perhaps on Twitter or Telegram? Is there? Go there. Back. Oh, there we go. I love it. You got to have a show at the end, you know.
If you go there, then you'll find all the.
Yeah. Big round of applause there for. Thanks. All right, cheers, guys. We've actually.